Okay, let's try one with a horizontal shift. This is a little bit trickier. 3 sine 2x minus pi on 2. Now, the first thing we have to do is rewrite this into the form that has a number out the front and then x plus or minus something. And we're going to do that by factorising what's in the brackets. It's 3 sine 2x minus pi on 4. How did I get 4? If I'm factorising 2, I'm effectively dividing each of these terms by 2, which gives me pi on 4. I need it in this form because then this is correct, and more importantly, the horizontal shift is easier to read off. So, what are the features of my graph? The amplitude is the number in front of the function, which is 3. And it's positive, so it's the normal orientation. The period is 2 pi over this number in front here, which is 2. So it's pi. This time there is a horizontal shift. The horizontal shift is pi on 4, but which direction is it, left or right? Well, adding a positive shifts it left. Adding a negative shifts it right. So I'm going to actually write here to the right. That helps me not get it wrong later. The vertical shift is 0. If there was a vertical shift, there would be another number added on to the very end of this. So my median line is still y equals 0. Okay, I think we know enough to get started. Let's draw in the axes. X and f of x. F of x. Doesn't really matter where I go. 3, go the same distance down, -3. Horizontal positions, 2 pi, pi 0 of course, pi on 2, and then 3 pi on 2. Now, it's actually easiest when you have a horizontal shift. It's often easiest to draw a version of the graph first without the horizontal shift and then apply the shift. As you get better, you may not have to, but I'm going to do it here. I'll use a different colour, a bit lighter, to draw in the unshifted graph, and then draw in my shifted graph in black as normal. So the unshifted graph, without the horizontal shift, has an amplitude of 3. It's positive, so it's upright, as usual. The period is pi. It's a sine graph, so we're going up. Period is pi, we're coming back to here again. Up, so we're going down in the middle and down in the middle. Maximum is up here, minimum is down here. Maximum and minimum. So the unshifted graph looks like this. It's not perfect, but it's good enough. Now what we're going to do is shift this graph from here by pi on 4 to the right. Now how big is pi on 4? Well, if that's pi on 2, this is pi on 4. So this one is 0 here, so it's actually only just getting here. I've shifted it this way by pi on 4. The maximum here is now pi on 4 further right. This centre point is now here. This minimum point is now here. This centre is now here. This maximum is now here. This centre is now here. And this minimum is now here. So I can now graph this. Now what's going to happen over on the left? Think about that while I connect this up. Whoops, didn't quite go through the centre there. All right, I've shifted my blue graph by pi on 4 to the right to get the pink one. Oh, I was going to draw it in black, wasn't I? Well, I've drawn it in pink now. What happens down here? Well, the blue one would have been going down to a minimum. So this is my minimum here, down there. As you get better, you don't actually have to draw in that initial graph. I just wanted to show you the translation as it happens, the shift as it happens, to help you get it right. So the pink one is the one I want. Pink is f of x equals 3 sine, and let me use the original label, sine 2x minus pi on 2. And let me label all the important points. This is 0, negative 3. This point is pi on 4, 0. This point up here is pi on 2, 3. This point is 3 pi on 4, 0. The minimum is pi negative 3. This 0 is 5 pi on 4, 0. This maximum is, what am I up to? Oh no, it's here, 3 pi on 2, 3. This 0 crossing point here is 7 pi on 4, 0. And we finish down here at a minimum of 2 pi negative 3.